Hello and welcome back. Let's continue looking at solving systems of equations with three variables and three unknowns. We'll just do a couple more examples. So with this system, we'll notice that this first equation doesn't have an x in it. But the way I've written it is very telling of how we would go about solving this. Even though there's not an x there, I've sort of left this gap there so that we have all of the x's in one row, one column, all of the y's in one column, and all the z's in one column. Doing this is not, let's say, necessary, but it is very, very helpful. It's very helpful when we want to try to cancel our variables out. So again, to solve a system of three equations with three unknowns, we want to reduce it to a problem that we can solve, or at least a lot easier. Let's say a system of two equations with two unknowns. So this first equation is already an equation with two unknowns in it. So it only has a y and a z. It doesn't have an x in there. So I don't have to do anything to that first equation. It's already an equation with only two variables in it. So what I want to do is I want to take the next two equations and solve them. What I'll do is, just like this first equation, I want to eliminate the x. So then I'll have two equations with only y's and z's in them. So how should I eliminate the x from these two? Well, let's write them down. X plus 2y plus z is equal to 17. 2x minus 3y plus 2z is equal to negative 1. And when I look at this, I want to eliminate the x. Just like there's no x up here, I want to eliminate the x down here. So what I'll do is I'll take the top and I'll multiply it by negative 2. Why? Because then I'll have a negative 2x and a 2x. So when I add them together, they cancel out. So again, here we will get negative 2x. Negative 2 times 2 is going to be negative 4. Negative 2 times z will be negative 2z. Negative 2 times 17 will be negative 34. And we'll have 2x minus 3y plus 2z is equal to negative 1. And here, when I add the negative 2x and the 2x, those guys will cancel. When I add the negative 4y and the negative 3y, I'll get negative 7y. Negative 2z and positive 2z, those also cancel. Oh, hey, that's going to be nice. Negative 34 and negative 1 will add up to negative 35. And right here, we notice I have one equation with only one unknown in it. That's so nice because I can take this. If I divide both sides by negative 7, I get y. Negative 35 divided by negative 7 is 5. So almost by accident, we have solved one of the variables. We know that y has to be equal to 5, and we know that because we just took these bottom two equations and combined them. So that's nice. So that's one variable down. But up here, I have an equation that's negative 2y minus z is equal to 7. So if I know what y is, the only thing left to figure out is z. Oh, that's nice. So then, again, let's write that down. So we've got 2y minus z is equal to 7. Yes, 7. So I know that y is 5. So let's plug that in. 2 times 5 minus z is 7. 2 times 5 is 10. I can subtract 10 from both sides. So I have minus z is equal to 7 minus 10 will be negative 3. Let's say multiply both sides by negative 1. So we cancel out that negative sign to get z is equal to 3. So far so good. Z is equal to 3, y is equal to 5. I now know what z and y are. I can figure out what x is. So I'm going to plug it into, let's say, the second equation there. That looks nice. So we've got x plus 2y plus z is 17. So x plus 2y plus z is equal to 17. But I know what y is, and I know what z is. And all that added together should be 17. So x plus the 2 times 5 is 10, plus 3 is 17. 10 plus 3 is, 13. So x should be equal to 4 once I subtract 13 from both sides. Okay, so we've got x is equal to 4, y is equal to 5, z is equal to 3. Let's plug this in and check. Let's just plug this into this bottom equation here. We've got 2x minus 3y plus 2z. 2x minus 3y plus 2z, and that should be equal to negative 1, so let's check. Y is equal to 5, x is equal to 4, and z is equal to 3. So 2 times 4 is 8, 3 times 5 is 15, 2 and 3 is 6, so 8 minus 15 is going to be negative 7, plus 6 is negative 1, and it all checks out. So the trick here is when we had an equation without with a gap in it, as in we didn't have an x, we just left that gap there so that we could see everything lining up. Because that first equation doesn't have an x in it, I want to use the other two equations to eliminate the x in there. But it just so happens that when we eliminated the x, we also eliminated z by accident, which is a good accident because then it gives us what y is. So let's do one final example, and this is an example, this is an application for what we can use solving systems of equations to do. So we want to find the quadratic function y is equal to ax squared plus bx plus c, and the graph should pass through these 3 points. So it should look something like, so we go 1, 2, 3, 1, 2, 3, 4. It should pass through this point, and this point. So something like that. But the question is, how do I come up with the equation for that line, for this parabola, when all I know is 3 points? And this is where the beauty of solving systems of equations come in. So remember that each of these is going to be the value for x and the value for y. So I can plug each of these in to get some equations, one for each point. So let's plug in this first one. So we have y is equal to 4, and that's going to be equal to a times x squared plus b times x plus c. And when I simplify this, we're going to get 4 is equal to, well, 1 squared is just 1 times a, so that's just a, plus b plus c. Okay, there's one equation. We've got 3 unknowns in it. Let's look at the next one. If I plug a 2 in for x, I should get y is equal to 1. So this would be a times 2 squared plus b times 2 plus c. When I simplify this, this is going to be 1 is equal to 2 squared is 4, so that's going to be 4a. That's just b times 2, so that's 2b plus c. You can begin to see where this is going. I've got 2 equations with 3 unknowns, and now I'll plug in this last one. So y is 4, and x should be 3. So a times 3 squared plus b times 3 plus c. So we will get 4 is equal to 3 squared is 9 times a plus 3 times b plus c. And we are well on our way. So I have 3 equations with 3 unknowns. All I need to do is figure out what a, b, and c should be, and we're done. And we've just been practicing solving three equations with three unknowns. So the first order of business will be to eliminate some variables. And because I've got C, C, and C here, I think it'll be easiest to eliminate some C's in here. So I'm going to take the top two equations and I'll try to eliminate that C. So so we've got the top two equations. 4 is equal to A plus B plus C. And 1 is equal to 4A plus 2B plus C. So the C's are the same sign, so if I want to add them together, I maybe want them to be opposite signs. So I'm going to take this top one, and I'm going to multiply it by -1. And we will get -4 is equal to -A minus B minus C. The bottom will stay the same. And when I add these together, the C's will cancel, which is exactly what I wanted. But then -B and 2B, so that's just 1B left. -A and 4A, that'll be 3A left. And -4 and 1 will give us -3. So I have eliminated C. Now I want to take, let's say, the second two equations, and I'll do the same thing. I'll take 1 is equal to 4A plus 2B plus C. We'll have 4 is equal to 9A plus 3B plus C. Again, the C's nearly cancel if the top one were negative, so I'll just take this top equation times 1, and we'll get -1 is equal to -4A minus 2B minus C. On the bottom, we still have the same thing. I'm not multiplying that by anything, so this is 9A plus 3B plus C. And what we see is that when we add these together, the C's will cancel, which is great. -2B and 3B, well, that just adds up to 1B. And -4A and 9A, well, that adds up to 5A. And -1 and 4 adds up to 3. Two equations, two unknowns. We are well on our way. Two equations. The first equation, -3 is equal to 3A plus B. Second equation, 3 is equal to 5A plus B. Oh, hey, look, the B's nearly cancel. Let's get them to cancel. I'm going to take the top equation by -1. And we will get -1 times -3 is 3, is equal to -3A minus B, the bottom. 3 is equal to 5A plus B. Add these together, the B's will cancel, -B and B cancel. -3A and 5A, that adds up to 2A. And 3 and 3, that adds up to 6. So we know that A, after I divide both sides by 2, is 3. Cool. Nearly done. Here's an equation of my two equations with both the A and the B in there. This is one of them, and I know that A is 3. So let's plug A is equal to 3 in there. So I've got 3 is equal to 5 times 3 plus B. So this is going to be 3 is equal to 5 times 3 is 15 plus B. Subtract 15 from both sides, and we get that B should be equal to -12. So now we know what A is, and we know what B is, and we can plug them in to get C. And I'm just going to use this top equation, since it's the simplest one. 4 is equal to A plus B plus C. So 4 will be equal to A is 3. B is -12 plus C. So 3 and -12 adds up to -9. So adding 9 to both sides gives us 13. And there you have it. Our solution will be y is equal to 3x squared minus 12x plus 13.